Before we look at other libraries, we're going to take a look at the TOMS library. I'll just bring up this here. It's in my sources directory, and there's an index.html, and it gives you a list of all the TOMS routines. So for instance, you have singular value decomposition of a complex matrix, and eigenvalues, eigenvectors, linear systems, sorting algorithms, complex gamma functions, all kinds of Bessel functions and whatnot. It's quite a broad-ranging library, and it's very useful to have. But I'm going to talk more at length on it because it's rather unusual. Many libraries are just like the ones we've seen, like BLAS. You have a whole bunch of source code in various .f or .c or .c++ files, whichever language the library is written in. You compile them all together and stuff them all into a library or an archive, and off you go. Now the TOMS library is not like that at all. Let's have a look in the source directory, and as you saw in the index there, everything has a number, file 454 and so on. Now each and every one of these is actually a Unix shell script, to unpack that particular piece of code and all its dependencies. So what I've done here, for instance, is I've decided to use 800 as an example. Okay, what you do, so you just obey the instructions. You remove everything above the hash exclamation mark line, and then you type in shell 800. You have to do that in your Cygwin terminal, otherwise your Windows terminal will not recognize what a shell script is. So we've got into our Cygwin terminal, and we've changed to a directory to toms/800dir, which is a directory we've made especially to install 800. It creates a documents directory and a Fortran 77 directory. Yes, you did hear me right, Fortran 77. And we have, under Fortran 77, we have drivers and source. So let's go to the source. What the script did was unpack everything into one single file called src.f. And what I've done is I've gone into src.f and split it up into separate Fortran files, and then compiled all the objects here. So what we did is gfortran -c star.f2 right angle bracket ers out. Now what the 2 and right angle bracket does is redirect all the errors and warnings into a file. If you just use the angle bracket on its own without the 2, it will redirect any normal write to the screen to whatever file you type. It will miss out all the errors and the warnings. If you want your errors and warnings to go into a file, you use 2 and the right angle bracket instead of just the right angle bracket on its own. Well, to sum up what we've done so far, we've created a directory called 800dir within our TOMS library. We've copied 800 to it, and then we did sh space 800 return, which basically says shell 800, and 800 is a shell script. We had to do that in the Cygwin terminal. Once we did that, we could get back to our normal command. We saw that the source directory was in a subdirectory called Fortran77 /dp/src. We compiled all the objects here, and then we did gfortran -o driver, that's going to be our executable file, and we just did star.o. We have the driver2.o file here, so we've compiled driver2, and then star.o will plug in all those object files that we just did, and as it said so in the instructions, we've linked it to the BLAS and LAPAC libraries. We get, yes, if we do it the other way around, we get a huge amount of error messages, so we actually have to put in the BLAS library second. Anyway, that gives us driver2, and there's driver.exe sitting over here, and then we can do driver. It doesn't actually tell you this, or doesn't make it completely obvious anyway, but data2 is the input file for driver. Otherwise, if you just run driver, it'll be sitting there waiting for you to type in loads of coefficients, which of course you don't know about unless you actually step through the code to find out what you're supposed to be typing in. Anyway, it's all in data2, so you can just use the left angle bracket to direct data2 into the standard input for the driver routine. And there we are, the scaled Hamiltonian is. I don't know what any of those numbers mean, but what it does mean is that we've successfully compiled this particular TOMS routine. Well, that's enough of the TOMS library. That's generally how you proceed, and of course you can't just build a whole load of code into a single library. You have to gradually build up the whole thing piece by piece. So we're certainly not going to do that at the moment. There's another big library called SLATEC. There we are. Well, I call it SLATEC anyway. Extensive software library in Fortran 90. It already includes various things from other libraries, and it's quite a good general purpose library. You can see B-array functions, Bessel functions, eigenvalues, all kinds of stuff in here, lots of complex stuff, sparse linear systems from the Harwell library. Some of these things are BLAS routines. I seem to recognize D dot, for instance, as a BLAS routine. But nonetheless, we can compile the whole SLATEC library. We're going to do that now, but before we do that, we'll just say that all of these are libraries that I've downloaded from NETLIB. So that includes FFTPack, FitPack, ODEPack. I've got a few other ones, CalSquad, QuadPack, SVDPack. But the only thing I'm going to compile at the moment is the SLATEC library. Anything else that I want, I can just compile it at the time. So let's get on with SLATEC. So libs sources, cd SLATEC. So what we're going to do is we're going to use the -C and the optimization O2 as we did with the LAPAC library and the BLAS library, and the -f recursive statement, and we'll just use a wildcard, so it's going to compile everything ending with .f, and hopefully away it will go. Okay, we'll have another go at that. This time we use the 2 and the right angle bracket to redirect any error and warning output to a file called ersout.txt. And let's see what ersout.txt will eventually contain. Okay, well that's finally done, and let's have a look to see what turned up in ersout. Warnings. So that's given us a warning. Oh, deleted feature assigned goto statement at 1. So some of them have assigned go-tos, but anyway, you still get the object files and build a library. We might have to recompile those if we hack those assign statements. We'll have to fix and recompile them if we ever actually want to use them, but the library should work as such. And if we do arcr libslatec.a star.o and then ranlib libslatec, so now we have our libslatec library as an archive. I've just got a little batch file here to compile all the DLLs, SLATEC imp and def. So let's do comp2. Let's have a look at comp2.bat minus L machine. And let's have a look at what library files we've got here. They're all at 1534, 1535, and we'll do move slatec.a c:/mylibs, move libstar c:/my DLLs. Let's have a quick look to see what's in there. And there we are, we've got liblapac, libblas and libslatec, and of course libmachine, which was missing from our compile statement. And now we can just remove all those object files to give us a bit more space. That's libslatec compiled and installed, and the other libraries that we have, as I said, we'll compile and install those as and when.